give you the tricks for integrating integrals that have a square root where both terms have a plus in front. So x squared plus a squared or a squared plus x squared. In that case, it doesn't matter. Before I give you the trick, let's look at a triangle. So in trick number 1, we place x here, a here, and the third side was a squared minus x squared square root. Now, to solve integrals like this, we want to build another triangle, but where one of the side is something like this square root. Well, since both are positive, that means the side with the root should be the hypotenuse. And so then I get to choose which of the side is x, which of the side is a. Well, just to make life easier, I'll take x to be here and a to be here, so that tan theta is opposite over adjacent is x on a, or x equals a tan theta. All right, so to get this square root as part of my triangle as one of the 3 lengths, I should take x equals a tan theta. That's the trick. X equals a tan theta, then dx. Well, that's not part of the triangle, that's just differentiating tan. So it's a secant squared theta d theta. I have my triangle, so let's put it here. And the only thing we need to make this trick complete and to be able to attack integrals is, what should I replace this with? Now, in the last trick, I proved what this was by taking the value of x and replacing it here and simplifying. And that would work here as well. But since we have the triangle here and we've used the triangle to deduce what x should be, let's use the triangle to deduce what the square root is. So square root is here, so I want hypotenuse over, I don't want an x, so I'm going to use hypotenuse over adjacent. That will be square root of x squared plus a squared over a. Adjacent over hypotenuse is cosine. If I want to flip it, I have 1 over cosine, that's secant. So secant theta would be equal to this. And so my square root is a secant theta. All right, that's the trick for integrals like this. It will also work for integrals that have x squared plus a squared in the denominator to whatever power. So for both these elements in your integrals, you should take x equals a tan theta, and everything else follows from that choice.